All right, on example 5, we don't know what the title says. Okay, let's pretend like we don't know. We're going to solve the triangle with this given stuff. Okay, so let's draw a little reference triangle of some sort. Okay, where, let's see, and I'm just going to label all of this. Angle B is 17 degrees. Okay. That means the side opposite is B. That's given to us to be 1 unit. And then we've also got side A. Let me let A be over here. That'll be 3. And so what we don't know is what is angle A. And then we don't know anything about the C's. So up here, let me call this angle C, and this would be side C. Those are the unknown parts. All right, so we have angle A, angle C, and side C. That's going to go in my answer box. Okay? All right, so what we're going to need to do is set up the law of sines. I'm going to say that we've got this pair here with the angle B with side B. Okay, and so I'm going to set up my law of sines to say the sine of 17 degrees is to side B, which is 1, as the sine of angle A is to side A, which is 3. Okay, now multiply both sides by 3, so I have 3 times the sine of 17 degrees divided by 1, I don't really need to write that, okay, is equal to the sine of angle A. Now we're going to solve for angle A by taking inverse sine of both sides. So inverse sine of 3 times the sine of 17 degrees is equal to angle A. Now, since we have the side, and non-included angle case, this is where we have to break this apart and say, well, we got 2 possibilities. We can have the acute angle, or it could go down like we have an obtuse angle, okay? Because sine is positive in both quadrants 1 and 2. So let's see. Angle A could be an acute angle, or angle A could be an obtuse angle. Let's see. Okay, so I'm going to say what angle has a sine value of 3 times the sine of 17 degrees? First of all, am I even going to have to mess with this? Let's see. 3 times the sine value of 17. Well, that is a decimal. Okay, that is a decimal between -1 and 1, so we're good to go. All right, so we know that this in here is 0.877, blah, blah, blah. So I'm going to say what angle has a sine value of that number, okay? Or I could punch in 3 times the sine of 17 degrees again if I wanted to. Oh, wait. I punched too much stuff. Okay, wait. Let me start over. Okay, I just want to say, I hit my sine key too many times. What angle has a, no. Back up. Okay, I want to say second sine, okay? I need to do inverse sine of the 3 times the sine of 17, so I'm going to hit, no, I'm not going to hit that. Yeah, I am, sorry, answer. I'm like, oh, crud. We're having a tough time here, people. I just want to hit second, answer. Okay, good. Finally, I'm asking my calculator, what angle has a sine of 3 times the sine of 17? Good gracious, let me hit equals. And it's like 61.3 degrees. That's going to be the acute angle. but then we also need to consider the obtuse angle. And we're going to find that by taking 180 minus the 61.3, and that's going to be 118.7. Okay? So we've got those two possibilities, 61.3 and 118.7. 61.3 degrees and 118.7 degrees. Those are two possibilities for A. I for sure like the 61.3 degrees, but then I also don't know if a second triangle exists here that has an obtuse angle of 118.7. Well, let's go in here and let's see if that is even a possibility. Now, if I come along here and I label angle A, okay, with the 118, let's look at it first. 118.7. If I take 118.7 plus 17, does that leave me enough for angle C? I think it does, okay? Because 118.7 plus 17 degrees only gives us 135.7, and we have enough left over to find angle C, okay? So angle C is going to be equal to 180 minus the 17 minus the 118.7, or 180 minus that, okay? That's going to leave us with 44.3 degrees. Okay? And let's go ahead and let's say that this is 44.3 degrees, and let's fill out our second triangle. So what I'm going to be doing is I'm going to be kind of subdividing my answer box here because I have a second triangle. Okay, we're going to focus on this one first. Okay, we have another possible angle A that has a measure of 118.7. Okay, if that occurs, angle C is, there in purple, 44.3 degrees. And then if that happens, we should be able, for that obtuse triangle, we should be able to find what is side C. Okay, so to do that for our obtuse triangle, I'm going to use law of sines. Okay, I'm going to say the sine of 17 degrees is to 1 as the sine of angle C is to C. Okay, so let's write that about right here. Okay, here's my law of sines so that I can find side length C. The sine of 17 degrees is to 1 as the sine of 44.3 degrees is to its side opposite, C. Okay? So to find C, we're going to cross multiply and divide. So sine of 44.3 times 1 divided by the sine of 17. Okay? So side C, when I take the sine of 44.3, okay, and I divide that by the sine of 17, because I just multiplied it by 1, right? Okay, there. We get side C could be 2.4, okay? Let's round to 1/10. Yeah, okay? So it could be 2.4 for our obtuse triangle, 2.4, okay? Now, we got the obtuse triangle, that second triangle. Now we need to go back here and we need to solve for this acute triangle. We're going to fill out, this column here. So what we should probably do is go edit some of this information within our triangle. Okay, I'm not going to leave the obtuse one in there. I'm going to put the acute angle. Okay, so for the case right here where our angle A is the acute angle, 61.3 degrees. Okay, then we're going to be able to find the measure of angle C is going to be 180 less the 61.3 less the 17 degrees, and that leaves us with the 101.7. Okay, C is 101.7. So actually we got another obtuse triangle, okay? But angle C is the obtuse angle. So it's 101.7 degrees. Okay? And now I need to find side C for my triangle. Okay? That's going to be a law of sines. So I'm going to again say the sine of 17 degrees is to its side opposite 1, as the sine of angle C, right now angle C is 101.7 degrees, is to side C. So to solve for C, cross multiply and divide. So C is going to be equal to 1 times the sine of 101.7 divided by the sine of 17 degrees. So punch that into your calculator, and that will yield that C in this triangle, is going to be, let's see, 3.3 units. Okay? So this is an example of where we have the two triangles. Okay? The two separate triangles. That a picture of that happening, remember, was when that the side opposite the given angle was just right to form two triangles. That triangle and this triangle, which may, if it's just right, also be obtuse. It could be acute or obtuse like we saw. Okay? So that was the case we saw in this last example. Always check for it, just in case.